Welcome to the Walton Pi. Today we're going to be tackling how to integrate secant cubed of x. If we were to just start with the integral of secant cubed, we might want to try first a u substitution, and we might try u equals secant of x. However, if we try u equals secant of x, then our du is going to be a secant x tangent x. And since there isn't a tangent x in this integral, that's not going to be able to help us out very much. Another thing we might try would be to make a substitution, where we replace secant squared of x with a 1 plus tangent squared of x, and that would break it down a little bit into integrals. But then the problem is we then have a tangent squared secant, which also is going to run into some problems, because then if we try u equals tangent, then we need a secant squared, which we don't have. If we try u equals secant, then du is secant x tangent x, but we have two tangents and not another secant, and so that one doesn't really work. And so because none of those methods worked, what we would probably try is to try and figure out, can we use integration by parts? And so if we're trying to tackle something by integration by parts, we need to figure out, is there a piece that is easy to integrate? So if we look at secant cubed, we could say, well, that's secant times secant squared. So the integral of secant, well, that's doable, but it's not something we would like to see showing up inside an integral, because the integral of secant is the natural log of secant plus tangent. And so we don't really want that to be our dv, because it is doable, but it's messy. But if we looked at the secant squared and say that's our dv, that ends up working out really nicely, because secant squared is the derivative of tangent. So if we break it up as secant of x times secant squared of x dx, then we can break this up and write this as the integral of u dv, where u is secant of x and dv is secant squared x dx. And so that tells us that u is secant of x and v is tangent of x, and so by integration of parts, this is going to become uv, so secant x tangent x, minus the integral of v du. So v is tangent of x, du is secant x tangent x dx. So that means we are left with the integral of secant cubed of x is secant x tangent x minus the integral of secant x tangent squared x. Now at this point we're like, well, great, we pulled out some of it, but it's still looking a bit messy. And so what we can do is we can try and figure out, well, can we do anything with secant x tangent squared x? Can we do a u substitution? So if we say u equals secant of x, then du is secant x tangent x, so that's not going to work. If we try u equals tangent x, then du is secant squared of x. Since we don't have two secants, that's not going to work. So that means our choices are now integration by parts or try and do a substitution. If we do a substitution, so we substitute tangent squared of x for secant squared x minus 1, this is going to give us a way that we can tackle this problem. So we now have secant cubed x dx, or the integral of secant cubed x dx is secant x tangent x minus the integral of secant x secant squared x minus 1 dx. If we distribute the secant x through the secant squared x minus 1, and then we rewrite this as two different integrals, this becomes the integral of secant cubed x dx equals secant x tangent x minus the integral of secant cubed x dx plus the integral of secant x dx. So that's what this is all rewritten. And notice that we have the integral of secant cubed x dx on both sides of this equality. So what that means is we can add that integral to the other side, and so now we have two integrals, secant cubed x dx is equal to secant x tangent x plus the integral of secant x dx. Now, if we can integrate secant x dx, that's going to help us figure this out. Now, the integral of secant x dx, that is something that is probably best just memorized because it's not super straightforward as to where it comes from. But the integral of secant is the natural log of secant plus tangent. So that tells us that 2 times the integral of secant cubed x dx is secant x tangent x plus natural log of the absolute value of secant x plus tangent x plus c. So we can divide everything by 2, and that tells us that the integral of secant cubed x dx is secant x tangent x plus the natural log of the absolute value of secant x plus tangent x all over 2 plus c. And so that is how we are able to integrate secant cubed x dx using integration by parts. This technique will also work if you have something like tangent squared x times secant x, or a bunch of other different things. Basically, try integration by parts. If u substitutions aren't working for any of the things that you're trying, integration by parts might work out. I hope this video was helpful in at least understanding how to integrate secant cubed x, and hopefully it was helpful in giving you ideas of how to integrate other things that you might run into. I hope you have a great rest of your day, and good luck with the rest of your math.